Hostler here. So what you guys are going to be doing is taking a look at the conservation of energy by analyzing the motion of, well, a guy on a skateboard. As you can see, we have him just going up and down on a half pipe right now. And you should be able to say, okay, well, we have a transformation of a gravitational potential energy. So when he's at his peak here, you should say, hey, every bit of energy he has is in gravitational potential energy. As he starts going down the ramp, his gravitational potential energy gets transferred to kinetic energy. In fact, you can actually take a look at this by looking at some various graphs. We have a bar graph, and you can see the total energy remains constant, and his kinetic and potential energies are changing. So, first thing, you guys are going to make some general observations about how energy is getting transferred from one form to the other. Now, one thing you will see is, hey, he keeps returning to the same height. This isn't very realistic, because if I were to do this, hey, I'm going to go a little bit lower, a little bit lower, a little bit lower. So one thing you'll say is, hey, there must not be any friction. So you can actually turn friction on the right-hand side as you see me clicking here, and that'll be something you take a look at a little bit later. So from here, you will be doing some basic track changes, so you can actually add and subtract pieces of track and connect them together by just dragging and dropping, hooking them, moving them around, and you'll make some observations and do some calculations from there. So the purpose of this lab is to get you to be comfortable with those kinetic energy calculations, 1/2 mv squared, some potential energy calculations, mgh, and the transfer between those two things. On the backhand side, make sure you're very careful and using correct formulas and doing those calculations, because that's something we are going to be looking at very carefully. Hostler out.